So we're going to finish up 4.6, and I'm sure some of you could figure this out on your own, but there is an important deal here. So if you notice, the directions for theta is these are in radians. So we want our answer in radians. And as a reminder, we always round to 3 decimal places. I guess I forgot to mention that before. But just like in previous problems, we'll solve for theta by doing inverse cosine, and you can type in this number. The issue, though, is that we need to change the mode in our calculator. So how do we do that? Well, let's go to mode, change it from a degree to radian, hit enter, and then just quit out of this. So now when you hit second cosine to do the inverse cosine, I already forgot what the numbers were, negative 0.9848. We get an answer of about 2.967. Now that answer should make sense, all right, because you should be a good critical thinker as you're doing all this work. Because if you think about where is cosine negative, there's 2 places that cosine is negative, in the second quadrant and the third quadrant. Well, if you look on the unit circle, it would take pi radians to get all the way over here to -1. Well, this is a little bit smaller than -1. And as a reminder, I'm not heeding my own advice, but pi is about 3.14, so it should be a number fairly smaller than 3.14. Okay, so that's one answer. We need to find this answer. Now, there's 2 ways of doing this, and maybe because this should be a short video, I'll go ahead and show you both ways. I would just think about, okay, well, this angle is 2.967, so this angle should also be 2.967. Well, how do I get there? I could just start at 2 pi radians, like doing a full revolution, and then going backwards, and to go clockwise is what that means, would be to subtract at 2.967. That's how my brain works. It doesn't always work for everybody. So I'm just hitting 2 second, this caret button will give me pi, and then minus second. The negative sign puts the answer in there. And you get 3.316. So the other theta is about 3.316. I'm just double checking that I copied correctly. Yep, rounded correctly. Which should make sense because this is in the third quadrant. It should be bigger than pi, 3.14. But as I mentioned, because some of you might not understand my way of thinking, is what you could do is find this angle in here. Well, you could find that angle by doing pi minus that 2.967. And then what you can think about is, okay, well, whatever answer that is has to have the same angle over here. Well, how do I write that out? You take that answer and add pi to it. And then that'll give you 3.316, because it should be the same answer. And that should make sense that we get the same answer, because what do you notice is my problem is a positive pi and a positive pi. Well, that is 2 pi, and we only subtracted that 2.967, which is exactly what I did. So I realize that some people don't think the way I do, so maybe my work here in pink made a little bit more sense. And then as we move on to cotangent, well, there's not a button in your calculator that does inverse cotangent. So what makes more sense for you is to rewrite this as tangent, because tangent's the reciprocal of cotangent. And then from here we can find theta by doing inverse tangent. And again, make sure you are in radians, the radian mode in your calculator, because this is not on the unit circle. Where's my calculator? There it is. So, are you in the right mode? Yep, we didn't change it. inverse tangent, and I just like to make the fraction, but you can hit the divided by sign. 1 divided by is the same thing. I already forgot what that number was, 5.671. You don't have to close the parentheses, but some people do, which that's fine. Hit enter, and you get an answer of 0.175. And I hope that makes sense to you. If you were to look on the unit circle, this is a very, very, very small number, especially considering on the unit circle. But tangent's positive, so we're in the first quadrant. And remember, tangent's sine over cosine. So if you were to think of a very small number, like right here is the ordered pair 1, 0. Well, 0 divided by 1 would be 0. So we need to be a little bit larger. I hope that makes sense, that you have to be a little bit larger. And remember, this is pi radians over here is pi over 2 radians. Now, pi over 2 is whatever 3.14 divided by 2 is, about 1.57. So obviously this answer should be between 0 and 1.57. Also, don't forget, though, that tangent is also positive in the third quadrant. And it should be exact the same. That's a terrible drawn picture. But anyway, a straight line on the other side. So all you have to do to get your other answer is to add pi, a line, straight line, 180 degrees. Although we're in radians, so you don't want to say adding 180 degrees. So add pi to that answer. And how to use your calculator, just hit plus, and the answer is saved. And then second, the caret button to grab pi, and you get about 3.316. Please notice that I'm not writing plus 3.14, and that's where other teachers will mark your answer wrong. They do not want that answer. Before moving on, earlier in this unit, we talked about how inverse cosine will find obtuse angles. So I do want to just touch base on this, and before you work in the homework, is like inverse cosine. I should mention, because other textbooks, they don't write inverse cosine, they write arc cosine. And the reason why, so let me write down, is the same as. Is because what the function is doing is finding the length of that arc. So that's why they call it this. And the reason why a lot of math people, myself included, use inverse cosine instead of arc cosine is because we learned earlier in this year about how to do an inverse. An inverse must pass vertical line test and the horizontal line test. So what that means is that we can only have one x value that's positive and one y value that's positive. So if you look on the unit circle, cosine is positive in the first quadrant, and if you continued on, then you get cosine is negative. And because your calculator can only give you one answer at a time, they give you everything from 0 degrees to 180 degrees, or 0 radians to pi radians, because that's where cosine is positive and negative. You can't do that for sine. So if you remember earlier in the year, I mentioned when we did the law of sines, and by the way, that's the same as arc sine. You might see another math book write that instead of inverse sine. But they're the same thing. Is on the unit circle, if you went from the first quadrant to the second quadrant, you're having the y values repeat, because sine is positive here and positive here. So what whoever thought of this decided to do is that the best option was to go into the fourth quadrant and go clockwise. So when you do inverse sine, you'll get negative 90 degrees to positive 90 degrees because that's the intervals that we use for sine being positive and negative. And the same thing is said for inverse tangent and arctangent. Well, speaking of it, those are the same things. Is tangent follows sine. I mean, my logic could be, the same as over here, but whoever invented this decided to say, okay, let's do inverse tangent from negative 90 degrees to positive 90 degrees. There's a reason, we just haven't learned it yet. So I wanted to touch base on that now that we've learned about inverse cosine, inverse sine, and this seemed to be the appropriate time to do so. And you should be ready for your homework.